All right, let's look over the sample test for precalculus on chapter 6. On this first equation, let's kind of rewrite it here. It's y equals, let's see, it's a minus 3 cosine pi. And if we factor the pi out of these two, we get the phase shift. So this is going to be x plus 1 over pi. And then we got a plus 2 on the end. That's kind of the order we used to seeing them in class. I rearranged them here so that you have to sort it out. So the amplitude is the absolute value of this, so it's 3. The midline, this whole graph is lifted up 2, so it's y equal 2, up 2. The period, 2 pi divided by the period is the number that's times the x, which is pi. So if I multiply by the period and divide by pi, I get the period is 2. And the phase shift is minus 1 over pi. That's the one that you're probably going to have the most trouble with. Need to have the constant with a 1 in front of the x. Factor out the constant in this, so we have to pull a pi out. So we're dividing this by pi to get 1x. So we're dividing this by pi, getting 1 over pi. Okay, number 2. These lines are kind of light, and I'm going to try to make them darker when I do the test. For some reason, it came out really light. This curve, it looks like it goes clear up to 4 and clear down to minus 2. So the midline must be halfway between that. So if I add these up, I get 2 divided by 2, getting the average. I get 1. And if I look at this, it does look like this is kind of the middle. It looks like it goes equally above it as below it. So the midline is plus 1. And it looks like it's starting on when x is 0, it's on the midline and going up. That's a sine curve. So it looks like this is the sine of something, and it's a plus 1 for the midline. Looks like it goes up from 1 to 4, so that's a rise of 3, and it goes down 1, 2, 3, so amplitude of 3. And the period, let's see. It looks like it completes a period if I follow pi straight up or straight up here. It looks like the period is pi. Not 2 pi, but pi. So that must mean that it's a normal period. If I just have sine of x, it'd be 2 pi. And to make it pi, I'm going to take 2 pi divided by the actual period, which is pi, and that says we need a 2 in front of there. And if I use the sign, so I don't have to shift it sideways, don't need a phase shift. So that would be the equation for this one. Now, this one looks like it goes from down, so there's 1 down, there's 2 down, so it looks like it's down 1.5, negative 1.5 for the low spot, and the high spot looks like it's 1/2. So it goes from 1/2 down to minus 1.5. So if I go minus 1 and 1/2 plus 1/2, that's minus 1. If I divide it by 2, I get See, this adds up to be -1 divided by 2. It's -1/2. So that's the midline. And there's 2, there's 1, there's the midline at -1/2. And it does look like it goes equally above and below that. In fact, it goes up 1/2 and 1/2. It goes one higher and one lower. So, and this one doesn't start on the midline. It starts down, not up like a cosine does, but down. So it's kind of like a negative cosine, a cosine curve flipped over, amplitude of 1. So I can put the 1 there. I don't need to. So -1 cosine. And let's see, and we'll get the midline in here. It's down 1/2, -1/2. And let's see, the period appears to be, well, it starts at the bottom here at 0, and by 2 pi it's at the top. Now, normal cosine curve, it would be all the way up and back down by 2 pi, so it only got half as much in there. So the full period must be 4 pi. So the number I put in front of the x is the normal period, 2 pi, divided by the actual period, which is 4 pi. And so that is 1/2. And since it starts right at the bottom, and that's what a negative cosine will do, there'll be no phase shift on that. This one. Now there's some subtleties in this one. You got to be real careful. This does look like a tangent. Cotangent would go this way and actually go from here down, start on this side of the axis. So this looks like a tangent to me. And let's see, if we go halfway between, it looks like the center line is right on 0. It's equally above and below here. So I have the midline of 0, so I could say +0 at the end, but I don't need to put that if it's 0. So let's do the amplitude. So halfway between 0 and the asymptote. Now this is a little tricky here. You can kind of see this, and it looks like it's up here. It's further away than here. So I don't think the asymptote is at pi. I think it's a little bit before pi, which I'm guessing is probably about 3 instead of 3.14. So the period appears to be from -3 to 3 or 6 before it when it starts to repeat itself. From here to here is 6, or from here to there, or from there to there is about 6. Not 2 pi, but just 6. The normal period for a tangent is not 2 pi, but pi. And if we divide that by 6, the actual period, we get to what should go in front of the x. Pi over 6x. And the amplitude, well, not really the amplitude, but we go halfway between 3 and 0, which is 1.5, halfway, and it looks like it's up at 1/2, not 1. There's 2, there's 1. Looks like it's about 1/2. So my estimate is going to be 1/2, and it's going this way, not this way, which would be a negative tangent. So that's my estimate for that one. And when we get these curves, you want to look at the curve that goes, the cyclic function, the sine or cosine, that would touch each one of these. Figure out the equation of that. So I'm going to do that first. So This is 2. This is looks like it's down 1.5. And this is down 1/2. So it goes from -1.5 to -1/2 back to -1.5. So the midline looks like it's about -1. So the midline is going to be -1. And if I'm just doing this curve at 0, it's at a peak. That looks like cosine. It looks like the amplitude, if it's at -1, is the midline, goes 1/2 above and 1/2 below. So I believe I have 1/2 here, and it's not negative because I don't need to flip it over. It starts at a peak. And the period appears to be exactly 2 pi. And the cosine's normal period is 2 pi, so I could just use an x. That would be this equation. But this is the reciprocal of the cosine, so the real equation is y equals 1/2. Reciprocal of cosine is secant x minus 1. Okay, page 2. So I want the exact values for these. Well, if sine of x is 0.7, so if I think about the unit circle, I'm just going to do it this way. If the sine is a positive 0.7, so I go some angle and I get a positive 0.7, here's 1, here's 1/2, so 0.7 is somewhere there, sine of 0.7. And if that's my x, if I go negative x, the same amount size angle, but negative, it looks like the sine of that negative angle is going to be the opposite of 0.7. It's going to be negative 0.7. It's going to be down 0.7. And what's the cosine? Well, of the negative x. Well, this is negative 0.7. This is 1, and so the cosine is this. And leg squared plus leg squared equals hypotenuse squared. So I'm going to get, or if you will, sine squared of x, negative x, plus cosine squared of the negative angle equals 1 squared, which is 1. And the sine squared, the sine here, negative 0.7 times negative 0.7 is a positive 0.49. That equals 1. I'll subtract that from here, and I get cosine squared of negative x is positive 0.51. And so if I take the square root, I'll find that the cosine of x is plus or minus the square root of 0.51 exactly. Now, if I did a decimal value, I wouldn't be getting the exact value. Now, on this one, if the tangent is 10, so if I'm on the unit circle, tangent clear up here, at way up here, 10, there's an angle with it. So if I go the negative angle of that same angle, I'd be down here, and the tangent of negative of that same angle would be a negative 10. Okay, exact principal value. So the sine inverse, the principal means the one Now the sine, when you're doing the sine inverse, you do it out of, see, sine is 0, it's positive here and negative here, so we do from minus pi over 2 to pi over 2, and minus square root of 3 over 2, square root of 3 over 2 is the longer side, and it's the minus, so it's got to go down, not up in this, so it's got to be right here, and we're supposed to do it this direction, because it's from minus pi over 2 to pi over 2. We can't go clear around. It's got to be this one. And that would be negative pi over 3. The angle whose sine is negative square root of 3 over 2. And the angle has to be between negative pi over 2 and pi over 2. This says the angle where the arctangent is the same as tangent inverse. So we're looking for the angle where the tangent is minus 1. Well, the tangent is 0 here, positive here, and negative here. So it's a negative 1, so we pick it out of here, and it's going this way. And again, it's from minus pi over 2 to pi over 2, so we can't use 7 pi over 4. We have to use minus pi over 4. That's the angle whose tangent, is minus 1. This says the angle whose secant is 2. Well, if the secant is 2, the reciprocal secant is cosine is 1/2. Now, cosine is positive in all of this, so we don't use this one. To get the negatives, we go from here to there. So the domain of the cosecant inverse is somewhere between 0 and pi. And we want cosine to be a positive 1/2, which is at pi over 3. Cotangent. Cotangent is not the tangent, but the cotangent line is here, and so you use these two quadrants, and it's negative. So if the cotangent is negative square root of 3, the tangent is negative 1 over the square root of 3. So the cosine is 1 and the sine is square root of 3, the longer one. So it goes here, and it has to be between 0 and pi. So we get an angle of 2 pi over 3. 5. Pi over 2 is 90. So this is a right angle. And so this one and this one, also in radians, are going to add up to be pi over 2. But we don't know either of those, so we have to use sides. And I can either use x or I can use y. Since x is the first one to find, I'll just say, let's see, this is for the x, that's opposite and adjacent. So the tangent of x is 21 divided by 17. So then I take the tangent inverse, and I should get x. And so I'll pull out my calculator, make sure my mode is in radians. It is. And so I'm going to do tangent inverse of 21 over 17. Tangent inverse of 21 divided by 17. And I get x to be 0.890 radians. And y is 90, or pi over 2 minus what x is. So I'm going to go pi divided by 2 minus my last answer, and I get y to be 0.681 rounded off radians. And finally z, well, that's just going to be a squared plus b squared equals c squared, so it's going to be 17 squared plus 21 squared, and then take the square root by going to the 0.5 power, and I get 27.02. Square root of 17 squared plus 21 squared. Okay. 6. Again, we don't know the angles. This is in degrees, so we'll do this one, and that says find x in degrees. Should have said y in degrees. So I'll find x. Let's see. X, this is adjacent, and this is hypotenuse. So that's cosine. Cosine of x is adjacent over the hypotenuse. So I've got to do cosine inverse to get rid of the cosine and find out that the x is, this is in degrees, so mod degree, and I got to do cosine inverse of 100 divided by 150, and I get x to be 48.19 degrees, rounded off a little bit. And if that's 90, these two have to be 90, so I can take that away from 90. 90 minus my last answer, and I get 41.81 for y. And I can use Pythagorean theorem to get z. That's going to be the square root of, let's see, 100 squared plus z squared, because that's a leg, and leg squared plus leg squared is the hypotenuse squared. So I got to do 150 squared minus 100 squared, and then square root. And so I'm going to do 150 squared plus 100 squared to the 0.5 to do the square root, and I get 180.28 is the length of z. Okay, what exact values on these? So the sine inverse means we take an angle. Again, the sine is 0 here, so here's negatives and positive, so we're going to do, that's positive, so we're going to take an angle in this quadrant where the sine is 3/7. That's 1, or 7/7, so 3/7 is about here, so it's an angle about that size. And then, and where the sine is 3/7, but we're supposed to find the cosine. And that's 1. So sine squared x plus cosine squared of an angle is 1. So if the sine is 3/7, that squared would be 9/49 plus cosine squared x is 1. Subtract that from 1, and 1 is 49/49. So if I take 9/49 from that, we get cosine squared x is 40 over 49, subtracting 9/49ths from both sides. And then I take the square root and I get the cosine of x is either plus or minus square root of 40 over the square root of 49 is 7. And 40 is 4 times 10, so I could call this plus or minus 2 square roots 10 over 7. But I can't go to decimal, so leaving it in either there or there would be the exact answers for cosine of x, cosine of this angle. Now we have sine of 7 pi over 6. So 1, 2, 3, 4, 5, 6, 7 6 is there. 30 degrees or pi over 6 down below 180 or pi. And the sign there is -1/2. Now this says find the cosine inverse of -1/2. But the cosine inverse we do from these two quadrants, and cosine is, these two quadrants, and cosine is -1/2 here, which is at an angle of 2 pi over 3. So it doesn't just give you that. You have to kind of think through what all this does. And finally, we have the cosine is -1/3. And so you do the cosine inverse between these two. And so if it's negative, and if this is 1, there's 2/3. -1/3 is about there, which means we got an angle here where this is -1/3 for the cosine. And we're supposed to do the tangent. Well, if we knew the sine, we could do the tangent. Hypotenuse is 1, so I'm going to do sine squared plus cosine squared equals 1. -1/3 squared, that's cosine squared plus sine squared of whatever this angle is 1. So this is 1/9 subtracted from 1, and 1 is 9/9, so 1/9 from 9, this is positive 1/9, and I subtract 1/9 from both sides, and I get the sine squared x equals 8/9, and so the sine can be of the angle is either plus or minus the square root of 8 over the square root of 9. And I could simplify that to 2 square roots of 2. The square root of 8 is 2 times 2 times 2. 2 of them come out as 2 square roots of 2. But I don't need to. Now, x is up here because the cosine inverse forced it to be there. So the sign has to be the positive one and not the negative one, because the principal value says use this one. And so now if I want to do the tangent of this, if we call it x, is the sine, so the square root of 8 over 3, positive, over the cosine, which is -1 over 3. Divide by 3, multiply numerator and denominator by 3 will cancel that out, and I get negative square root of 8 or -2 square roots of 2 if I simplify. Either one of those is correct answer for C. one more page. And this one turns out to be pretty messy. Okay, so if we're going to solve for x, we're going to unwrap it. We're going to subtract the square root of 2 from both sides and divide by 2. I think you can do that in your head. So we're going to get cosine 3x is minus square root of 2 over 2. Subtracting the square root of 2 and then divide by 2. So now I got to do cosine inverse. And I want all the solutions between 0 and 2 pi. So I'm going to write what all of them look like, not just between 0 and 2 pi. So when is the cosine this? Which, by the way, is the same as minus 1 over the square root of 2. And that happens on a 45 or pi over 4. And the cosine is minus here. So it'd be here or here, where the cosine is minus 1 over the square root of 2, or minus square root of 2 over 2. So this angle is 3 pi over 4 plus multiples of 2 pi. And this one is 5 pi over 4 plus multiples of 2 pi. There's all the solutions for 3x. So now to find the solutions for x, I have to divide everything by 3. So this one goes to x is equal to, if I divide that by 3, I get pi over 4 plus multiples, and if I divide that by 3, I get 2/3 pi. And similarly, if I divide by 3, I get 5 pi over, well, 3 doesn't go into that, so I'm going to be multiplying by 1/3, so 5 pi over 12, and that will be the same, plus multiples of 2/3 pi. There's all of the possible solutions for this, but I just got to find the ones between 0 and 2 pi. So I have pi over 4, that's one of them, plus none of this. And then I got to do pi over 4 plus 2 pi over 3. So the common denominator is 12, so I'm going to think of this in terms of 12. So this is 3 pi over 12. So this one is 3 pi over 12 plus, and in 12ths, I'd have to multiply by 4. This is 8/12 pi. So here's 3 pi over 12, pi over 4. And 3 pi over 12 plus 8 is 11 pi over 12. That's still less than 2 pi. Add this again, another 8 to this, and I would get another 8/12 pi, and I get 19 pi over 12. That's still less than 2 pi. It'd have to be 24 over 12 to be 2 pi. But if I add another 8, I'm going to be at 27, so that's too big. So those answers come from this, and now I got to do this. The first one would be 5 pi over 12. And this again is 8/12, so I'm going to add 8 to 5, and I'm going to get 13 pi over 12. And if I add again, I'm going to get 21 pi over 12. And if I added 8/12 again, I'd get beyond the 24 over pi over 12, which is 2 pi. And so this is my list of answers. That one was a challenging one. This one's much easier. Again, we've got the 1 on the other side, so I just have to divide by 2, and I have sine of 0.5x equals 1/2. So I got to do sine inverse and get 1/2. So if I think of my unit circle, and the y value is plus 1/2, happens at pi over 6 plus multiples of 2 pi. And it also happens here where it's a half, which is 5 pi over 6 plus multiples of 2 pi. And that's what the 0.5x has to equal. Well, that's 1/2, so to get rid of the half, I have to multiply by 2. So x in general is 2 pi over 6, or pi over 3, plus multiples of 4 pi. Or, multiplying by 2 here to get rid of the half, x is going to be 10 pi over 6 plus multiples multiplied by 2, 4 pi. Now, of these, which ones are between 0 and 2 pi? So I'm going to rewrite this as pi over 3, reducing the 2/6, plus multiples of 4 pi. And this is going to be 5 pi over 3 plus multiples of 4 pi. So pi over 3 plus no 4 pi's is one answer. And if I add 4 pi, I'm going to be beyond 2 pi. And if I subtract 4 pi, I'm not. So that's the only one from this piece. And 5 pi over 3 is between them. And any multiple of 4 pi added to that would be too big, or subtracted be too small. So I only get 2 answers. So now this just says find the solutions in radians. So you divide by 3 on both sides, and then do tangent inverse. In mode radians, and so I go tangent inverse of 5 divided by 3, and that gives me one place where the tangent is 1 2/3. 1 is here, and 2/3 is up here. So there's an angle here, and it's telling me it's 1.03 radians. So one answer, approximate, it doesn't say exact here, so I can go 1.03 plus m2 pi. But the other place the tangent hits there is over here, which is 1.03 plus pi. That takes me clear over to here, plus multiples of 2 pi. Or I could just say it's 1.03 plus multiples of pi, because if I go to here and add pi, I get to there, and add pi again, and add pi, and add pi, or go to here and subtract pi, subtract pi, subtract pi, and I end up where the two places where the tangent is 5/3. So either that set of answers or that answers. Cosecant. So I divide by 4, and the cosecant of 2x is 5/4. So that means the sine of 2x is 4/5. So I do sine inverse of 4/5. Oops, 4 divided by 5. And I get 0.927. 0.927 plus multiples of 2 pi, or for sine, it's 4/5, almost all 5/5, 4/5. It's up here. That would be the angle, this angle. Or it would be pi minus that angle. So the other one is pi minus that, pi minus my last answer, and I get this angle to be 2.21 plus multiples of 2 pi. And that's what the 2x equals. So now to find all solutions, I have to divide by 2. So this becomes 0.9 divided by 2, 4, 6, 4 approximately, plus multiples of pi, dividing that by 2 and that by 2. I rounded it off. And on this one, I'm going to divide by 2, which is about 1.101 plus that divided by 2 is multiples of pi. So there are my answers for x in that one. Now this one looks like a quadratic, so I'm going to subtract the 1 over, and I'm going to say it's 4 sine squared x minus 3 sine x minus 1 equals 0. This looks to me like 4x squared minus 3x minus 1 equals 0. That's what I'm seeing. Sine x is like an x. It's an unknown. This factors 2, 4x and x. And if I put minus 1 here, I get minus 4x's, and plus 1 here, I get plus 1x, which is minus 3x. So I have 4, it's not really x, it's sine x plus 1 and sine x minus 1. And if these two multiply to be 0, then either 4 sine x plus 1 equals 0, or sine x minus 1 equals 0. So if I subtract 1 and divide it by 4, I get sine x equals minus 1/4, or sine x equals 1. So pulling up a calculator, doing sine inverse of negative 0.25 or 1/4, I get negative 0.253 plus multiples of 2 pi. And again, the sine has 2 places, the angle and 180 or pi minus that angle. So I got to go pi minus my last answer, and I get 3.39 plus multiples of 2 pi. Those are values that work for this part. Then I got to get this one, and there's one place where the sign is 1, and that's at the very top at pi over 2 plus multiples of 2 pi. So there's the answers to that one. Now you're seeing that there's a lot of this. I'm going to have to reduce that because this would take way too long to do on a test. So just so you know, this is too long for a test. But I will have something like this. We've done several problems similar to this. A Ferris wheel with a diameter of 10 meters means the radius is 5 meters. Is going to go around, and it has a, they're entering it at 2 meters high. So the seat on it's going to go from 2 up to 12, back to 2, and write an equation for give the height of the seat as it starts at the bottom of the Ferris wheel at time 0, and it takes 8 seconds to do one complete round. This is a fast Ferris wheel. So the height, let y be the height, so we'll let y be the height. The amplitude is going to go from 5 below the center to 5 above the center. So the amplitude is 5, but it starts at the bottom. So I'm going to use the cosine curve and make it negative so it could start at the bottom and go up and down, and then up and down. So it's starting at the bottom, going up to the height of 2 plus 10, 12, and going, starting at a height of 2. The midline, therefore, is at 2 plus 5, or 7. That's what we add at the end. And now I just got to get the period right because it starts right on it. And it says it's 8 seconds, so we got to do 2 pi divided by 8, which is pi over 4 times the time. They said use t for the time. So there's the equation. Let y be the height above the ground. Determine the first time the seat reaches a height of 10. So we'd set this equal to 10. Now, we could do just like we did on this or this or this or any of the other problems. We can, if we said this is 10, we could subtract 7, divide by -5, do the cosine inverse, and then that. I'll go ahead and do that. Subtract 7 and divide by -5, so I'm going to get 3 when I subtract the 7, divided by -5, and that's the cosine of pi over 4t. So I can do the cosine inverse of -3/5. And I get 2.2 plus multiples of 2 pi, but I won't need it because I want just the first time, and it's going to be coming up here. And the first time it reaches 10 is going to be about here. So it's, if this is 8, this is 4, so it's about 3 seconds. It's going to be up there. 1001, 1002, 1003. Anyway, so the pi over 4t, since I did the cosine inverse of this, to get rid of the cosine, and I got this answer, I need to multiply both sides by 4 over pi. So that's 8.8 divided by pi. So 8.8 divided by pi, and it reaches there at 2.8 seconds. Now I could have got that also by just graphing my equation. My equation was -5 cosine of pi x divided by 4. Pi x divided by 4, close parenthesis, plus 7. And I want to know when that equals 10. So I'm going to go zoom 6, and 10's right at the top. And where these intersect is what I want. So I'm going to go second, calculate the intersection of the blue curve, yes, enter. The red curve, yes, enter. And my estimate is about there. Press enter, and it says 2.819. And we had 2.8.